For generations, we believed the boundaries of our solar system were well understood. The planets ended, darkness took over, and beyond that, space simply dissolved into mystery. But when Voyager 2 crossed what should have been the final edge, the information it transmitted back to Earth did not describe a void. It revealed structure. It revealed transformation. And most unsettling of all, it revealed a sudden transition so sharp that scientists were forced to confront an uncomfortable truth. The solar system does not fade gradually. It ends. When Voyager 2 crossed that line, plasma vanished, particle behavior abruptly shifted, and magnetic fields snapped into an entirely new configuration. This outcome was never predicted. Some scientists described it as a wall. Others called it a shield. And a few asked a much darker question. What exactly did Voyager 2 enter? Voyager 2 began its journey in 1977, launched during a rare planetary alignment that allowed it to visit Jupiter, Saturn, Uranus, and Neptune before continuing outward toward the unknown. Decades later, after passing the giant planets, the spacecraft reached a region no human-made object had ever explored. Beyond the planets, past the Kuiper Belt, and far beyond the distant reach of the Oort cloud, Voyager 2 approached the boundary of the heliosphere, the vast magnetic bubble inflated by the solar wind that shields the solar system from interstellar space. Scientists expected this boundary to be chaotic and gradual, a slow blending of solar influence into the surrounding galaxy. Instead, Voyager 2 recorded a sudden collapse in solar wind particles, a sharp rise in high-energy cosmic rays, and a dramatic shift in magnetic field orientation. This was not a slow transition. It was a crossing. In a single moment, Voyager 2 exited the Sun's domain and entered a region governed by the Milky Way itself. The data was so clean and abrupt that it stunned researchers. The solar system, it turned out, has a real edge, and Voyager 2 had just passed through it. What shocked scientists even more was not simply that Voyager 2 crossed the boundary, but how that boundary behaved. Plasma, once abundant inside the heliosphere, nearly disappeared beyond it. Particle densities plunged. Temperatures shifted in unexpected ways. Instead of a turbulent mixing zone, Voyager 2 detected a narrow, sharply defined region separating two entirely different environments. On one side, hot, sparse heliospheric plasma shaped by the sun's magnetic field. On the other, colder, denser interstellar plasma governed by galactic forces. Even more surprising was the magnetic alignment. Researchers had anticipated chaos, twisted field lines colliding at odd angles. Instead, Voyager 2 found that the interstellar magnetic field aligned closely with the heliospheric one, revealing a far more ordered and coherent boundary than anyone had imagined. With this discovery, the heliopause stopped being a theoretical construct and became a measurable structure with thickness, behavior, and form. The edge of the solar system was no longer an idea. It was something Voyager 2 physically encountered. Voyager 2 crossed the heliopause at a distance nearly 1.6 billion kilometers closer to the Sun than Voyager 1. That single detail carried enormous implications. It showed that the heliosphere is not spherical. It is distorted, compressed, and shaped by pressure from the interstellar medium. The solar system is not a perfect bubble drifting peacefully through space. It is being pushed, dented, and reshaped by forces beyond our star. Unlike Voyager 1 at the time, Voyager 2's plasma instruments were still fully operational. They recorded unexpected particle behaviors, including streams of high-velocity plasma and non-thermal pickup ions that defied existing models. Temperatures beyond the termination shock were lower than predicted, suggesting energy was being redistributed in ways scientists did not yet understand. Together, these measurements revealed a boundary that was dynamic, complex, and far more active than previously believed. The Sun does not simply fade into the galaxy. It negotiates with it. Voyager 2's data forced scientists to confront a deeper realization. The heliosphere is not just a boundary. It is a shield, a filter that protects the planets from much of the high-energy radiation that fills the Milky Way. As Voyager 2 entered interstellar space, cosmic rays surged while solar particles nearly vanished, confirming that life inside the solar system exists within a carefully moderated environment. This discovery carries profound implications for future human exploration and for understanding how habitable regions survive around stars. Alongside its scientific instruments, Voyager 2 carries something else, a philosophical message. On board is the Golden Record, a time capsule of humanity now drifting beyond the sun's influence. Long after Earth has changed beyond recognition, Voyager 2 will continue onward, carrying proof that a technological civilization once existed inside this fragile magnetic bubble. Its data is not just scientific. It is a reminder that our home is finite, protected, and far more vulnerable than we ever imagined. One of the most unsettling realizations from Voyager 2's data is that the solar system's edge is not calm or passive. It is energetic. It is active. It is under constant stress. As Voyager 2 approached the heliopause, instruments detected compressed plasma layers and shifting magnetic conditions, suggesting the solar wind does not simply stop. It piles up against an opposing force. The solar wind slows, heats, and destabilizes, as if pushing against an invisible barrier that refuses to give way. This region behaves less like empty space and more like a pressure zone where two immense systems collide and adjust. Voyager 2 revealed that the heliosphere is continuously squeezed by the surrounding interstellar medium. The solar system is not floating freely through the galaxy. It is being actively shaped by it, moment by moment. Voyager 2 made it unmistakably clear that the heliosphere functions as a protective system. Inside it, solar particles dominate and galactic radiation is partially deflected. Outside it, that balance reverses instantly. As Voyager 2 crossed the boundary, high-energy cosmic rays surged while particles from the sun nearly vanished. The boundary acts as a powerful filter separating two radically different radiation environments. Every planet, every mission, and every form of life that has ever existed in the solar system has done so inside this shield. By crossing the heliopause at a different distance than Voyager 1, Voyager 2 reshaped how scientists visualize the solar system itself. The heliosphere is asymmetric, compressed in some regions, stretched in others, molded by uneven galactic pressure. The sun's domain resembles a windswept vessel rather than a perfect sphere. The galaxy exerts real force on our star's territory, reshaping how far its influence can extend in any direction. For decades, scientists relied on simulations to imagine the solar system's edge. Voyager 2 exposed the limits of those assumptions. The sharp transition, magnetic alignment, unusual plasma behavior, and structured boundary contradicted long-held models of a gradual fade. Reality was cleaner, harsher, and far more complex. Voyager 2 did not simply collect data. It forced a reckoning. Textbooks were rewritten. Theories were revised. A region that once existed only in equations became a place. As Voyager 2 continued, transmitting from beyond the heliopause, a deeper realization emerged. The boundary is not a single line, but a layered system that responds to pressure, density, and magnetic alignment. The sun's influence does not terminate cleanly. It interacts with the galaxy across a structured interface that shifts and breathes over time. Scientists expected a gradient. They found architecture. Voyager 2's functioning plasma instrument allowed direct measurements of density, temperature, and motion. What it recorded puzzled researchers. Plasma temperatures were lower than expected. High-velocity streams appeared where calm was predicted. Energy did not dissipate smoothly, it organized. This was not random turbulence. It was structured behavior emerging from a region once assumed chaotic. The space between the sun and the galaxy is governed by rules we are only beginning to understand. The more the data was studied, the clearer one truth became. The heliosphere exists in constant negotiation. The sun pushes outward. The galaxy pushes back. The boundary Voyager 2 crossed is where those forces reach temporary balance. When the solar wind weakens, the boundary retreats. When it strengthens, the heliosphere expands. The boundary is not fixed. It moves. Perhaps Voyager 2's most profound contribution is perspective. For the first time, humanity is viewing its home from the outside. Every moment of human history unfolded inside the heliosphere Voyager 2 left behind. Beyond it lies a colder, denser, more energetic environment that does not care about planets or life. Voyager 2 is now sampling that reality directly. Beyond the heliosphere, protection vanishes. Plasma grows denser and colder. Solar particles fade. Cosmic rays surge. Interstellar space is not passive. It is pressurized and hostile. Voyager 2 showed that the sun's shield ends abruptly, and what lies beyond is immediately harsher. Even magnetic fields defied expectations. Instead of chaos, Voyager 2 found alignment. The boundary resembled an interface, not a battlefield. This raised unsettling questions about how deeply the galaxy penetrates our defenses. Voyager 2 also revealed that the heliosphere is not permanent. Its size changes as the solar system moves through regions of varying density. In denser galactic zones, the shield may compress, allowing more radiation inward. Our safety is conditional. For the first time, Voyager 2 gave humanity an outsider's view of its home. From beyond the heliosphere, the solar system is finite and contained. The sun is just another star. Voyager 2 is no longer exploring our space. It is exploring the galaxy's space. When scientists compared the data to decades of models, the mismatch was undeniable. Expectations failed. Voyager 2 proved the boundary behaves like a balanced interface, not a fading horizon. Without it, we would still be arguing whether Voyager 1's data was an anomaly. As the full picture came into focus, one final truth settled in. The solar system does not own its territory. It occupies it temporarily. The heliosphere exists only as long as the sun can hold the galaxy at bay. Voyager 2 showed that this balance is delicate. The solar system does not fade. It stops. Voyager 2 crossed that stopping point and sent back a message humanity cannot ignore. Our home exists by balance, not permanence. Long after Earth changes beyond recognition, Voyager 2 will continue drifting between the stars, carrying proof that one civilization reached the edge of its cosmic shelter and dared to look beyond. Space doesn't fade. It pushes back. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.